Morning, dear students. Today we will learn about solution of system of linear equations by Gauss-Jordan method. In previous class, we learned two methods for solution of linear equations. The two methods are one is inversion method and another one is Cramer's rule. So in this matrix, another method is there, that is Gauss-Jordan method for solving the linear equations. So let us see. Objectives. On completion of this period, you would be able to know the Gauss-Jordan method, solve the system of linear equations by Gauss-Jordan method. Recap. What are the elementary row operations? Interchanging of two rows, multiplying the elements of any row by a non-zero scalar, adding to or subtracting from the elements of one row corresponding elements of any other row multiplied by a non-zero scalar. So, Gauss-Jordan method for solving a system of linear equations. Consider the equations a1x plus b1y plus c1z equals to d1, a2x plus b2y plus c2z equals to d2, a3x plus b3y plus c3z equals to d3. It can be written in the matrix form as a1 b1 c1, a2 b2 c2, a3 b3 c3 into x y z, that equals to d1 d2 d3. That is ax equals to b, where a equals to matrix a1 b1 c1, a2 b2 c2, a3 b3 c3, and x equals to x y z, and b equals to d1 d2 d3. Then the matrix AB, we can write a1 b1 c1 d1. Here d1 is written as a fourth column, but here looking it's some far away from c3, but you can write little bit near to the c3, as c2 c3 how much gap is there, similarly maintain the c1 d1 also. So next second row a2 b2 c2 d2, a3 b3 c3 d3 is called augmented matrix. Augmented matrix means total. Here a and b we are taken a b, so that's why we are calling augmented matrix. So by using elementary row operations, we obtain the equivalent matrix in the form we know in previous class knew how to operate row operations. So by using that row operations, we have to bring the form into this matrix type, that is 1 0 0, and the last element of first row is alpha. Next, so 3 rows and 3 columns should be in a unit matrix or identity matrix, that is 1 0 0 0 1 0 0 0 1, and last column is whatever it is comes, that we say alpha beta gamma, that is fourth column. So if in this form we bring the AB matrix, then we can directly say x equals to alpha and y equals to beta and z equals to gamma will be the solution of the given system of equation. Because if you observe, we are using here row operations. So if we observe the first row how we took, that is x coefficient, y coefficient and z coefficient and constant. So here in the first row, if we frame, that is 1 0 0 means 1 means x and y z are 0, so x equals to alpha. That is here the logic. So row operations means we are solving the equation 1 2 3 to cancel y and z in first row, and in second row 0 1 0 means y is 1 and remaining are, we are showing null, that means x and z are 0. That means we are removing x and z by solving. Here solving means we are applying row operations. And similarly third row, if you observe 0 0 1, that means x 0 y 0 and z only there, so that is z equals to constant, that is gamma. So, and we have to remember one thing, in this Gaussian we use only row operations, not column operations, because row operations means here we are solving 1 and 2. So that means we are adding or subtracting like x to x and corresponding elements, y to y, z to z, corresponding coefficients also. So here in generally we solve means from equation 1 and 2, and if we are multiplying or dividing to total equation 1 or 2 because of cancellation of x or y or z. Similarly here we are doing in the matrix. So same procedure as we learned in previous classes, that means 10th class, how to solve the equations. So here also same, but we are framing in a simple way by using matrix row operations. So we are need not to take 1 2 3 equation 1 and equation 1 multiplied with so and so coefficient of second equations, like so that is, covers in the row operations. That is the difference only. So see here, and working method for Gauss-Jordan method. Form the augmented matrix AB. Second, make the point first element of the first row as 1 using elementary row operating. R1 gives k into R2, k into R1 is gives k into R1, R1 changes k into R1, and R1 interchanges R3, R1 R3 are interchanges if there is other row having 1 as first element. Now the third point, now use the elementary row operation Ri, use Ri minus m into R1 for I equal to 2 3 to make the first elements of the second and third rows as zeros. Then the augmented matrix will be transformed into the form 1 A12 A13 K 0 A12 A23 L 0 A32 A33 M N KLN. Use the elementary row operations. R2 gives 1 by A22 into R2, or any other row operations involving R2 and R3. Don't use R1 to make the second row, second column element as 1. Use the elementary row operations. Ra gives Ra minus k into R2 for I equals to 1 comma 3 to make the second element of row 1 and row 3 as zeros. So if you read these points or observe these points, you can not understand clearly, but when we do the problem, we can easily understand. Simple. Overall, we are converting or we are transferring like unit matrix of 3 by 3. For that, we are doing dividing or adding or subtracting or multiplying with so and so row and adding with so and so row. That is here giving in the points form. Seventh, use the elementary row operations. R3 gives 1 by A33 into R3 to make the third element of the row third as 1. Eighth, use the elementary row operations. Ri gives Ri minus k into R3 for I equal to 1, comma 2, make the third elements row 1 and row 2 as zeros. Finally, the augmented matrix will be transformed to the form 1 0 0 0 1 0 0 0 1, and last column is alpha beta gamma, which implies x equals to alpha, y equals to beta, and z equals to gamma. Note: never use column operation in Gauss-Jordan method, because if we are using column means again we are mixing x y, so that is not a proper solution, because we are solving equations when in previous class, that is 10th class, we learned by removing x or y or z. So we are at that time, we are, if two equations are there, that means if we either cancel the x or cancel the y by adding or subtracting. So from in two equations, from one equation to another equation, we are right and we are subtracted or added corresponding elements of x or y or z are constants. So that is here applied. That's why we are using row only. See, when we are, if two equations are taken, we are adding means x we will add and y we will add, z we will add. That means row to row. That's why we are saying only row operations in Gauss-Jordan method. See one problem, then you can easily understand these points. And here we are need not to remember any type of formula. That is the easiest method, we can say. So question is, solve the equations 2x minus y plus 3z equals to 9, x plus y plus z equals to 6, x minus y plus z equals to 2 by Gauss-Jordan method. So solution, the augmented matrix is 2 minus 1 3 9 1 1 1 6 1 minus 1 1 2. First we need 1. First row, first element should be 1. So here we have 1 is in the second row. That's why applying interchange of R1 and R2. So R1 comes to R2 position and R2 comes to R1. That is the interchanging means. So here we are interchanging R1 as R2. So R2 comes to the R1 position. That is 1 1 1 6 2 minus 1 3 9 1 minus 1 1 2. Next, applying R2 minus 2 into R1, because in the first column we need 1 0. 0 means we are doing R2 minus 2 R1. Next, in the third row, first element also we need 0. That's why we are doing R3 gives R3 minus R1. So then we get identically equals to, the symbol is we can say read as identically equals to 1 1 1 6 0 minus 3 1 minus 3 0 minus 2 0 minus 4. So applying R2 gives minus 1 by 3 into R2, because in the second row, second element, we need 1. So that's why we are doing that. So 116 to 1 minus 1 by 3, 1, 1 minus 2, 0, 4. Then applying R1 gives R1 minus R2, and see here, second row, that is not 2. Second row, first element, that is 0. Here wrongly printed 2. So and R3 gives R3 plus 2 into R2, because second column we need 0, 1, 0. That's why we are doing this. So that is identically equals to 1, 0, 4 by 3, 5, 0, 1 minus 1 by 3, 1, 0, 0 minus 2 by 3 minus 2. Applying R2 gives minus 3 by 2 into R2. That is identically equals to 1, 0, 4 by 3, 5, 0, 1 minus 1 by 3, 1, 0, 0, 1, 3. Applying R1 gives R1 minus 4 by 3 into R3, and R2 gives R2 plus 1 by 3 into R3. Then that is equals to 1, 0, 0, 0, 1, 0, 0, 0, 1, and last column is 1, 2, 3. Therefore, by Gauss-Jordan method, the solution is x equals to 1, y equals to 2, and z equals to 3. So if we substitute these values in any equation, we will get the right side constant. So this is the solution how we solve. And second question is also there. See, solve the equations x minus 2y minus z equals to minus 1, x minus y minus z equals to 0, 2x plus 3y plus 2z equals to 5 by Gauss-Jordan method. Same as above we did. See here, solution. The augmented matrix is 1 minus 2 minus 1 minus 1. And second row, 1 minus 1 minus 1, 0. Here first 3 columns are x, y, z coefficients, and last column is constants. So 2, 3 to 5. Applying R2 gives R2 minus R1, and R3 gives R3 minus 2R1. So here R2 and R3 are changes. That is identically equals to 1 minus 2 minus 1 minus 1, 0, 1, 0, 1, 0, 7, 4, 7. Applying R1 gives R1 plus 2R2, and R3 gives R3 minus 7R2. That is identically equals to 1, 0 minus 1, 1, 0, 1, 0, 1, 0, 0, 4, 0. Applying R3 gives 1 by 4 R3. That is identically equals to 1, 0 minus 1, 1, 0, 1, 0, 1, 0, 0, 1. Applying R1 gives R1 plus R3. That is 1, 0, 0, 0, 1, 0, 0, 0, 1, 1, 1, 0. So therefore the solution is x equals to 1, y equals to 1, and z equals to 0. Another question is there. Solve the equations x plus y plus z equals to 6, x minus y plus z equals to 2, 2x minus y plus 3z equals to 9 by Gauss-Jordan method. Solution. The augmented matrix is 1, 1, 1, 6, 1 minus 1, 1, 2, 2 minus 1, 3, 9. Applying R2 gives R2 minus R1, and R3 gives R3 minus 2R1. Then we have 1 1 1 6, 0 minus 2 0 minus 4, 0 minus 3 1 minus 3, and applying R2 gives minus 1 by 2 into R2. Then R2 changes as 0 1 0 2. Next, applying R1 gives R1 minus R2, and R3 gives R3 plus 3 R2. Therefore, R1 is 1014 and R3 is 0013. So, applying R1 gives R1 minus R3. Then we get 100, 010, 001, and the fourth column is 1 2 3. Therefore, x equals to 1, y equals to 2, z equals to 3. Another question is also given. So same as above we did, you can observe and you can see here. And finally, the AB is changed as a 100, 010, 001, and last column is 111. The solution is x equals to 1, y equals to 1, and z equals to 1. Same, the fifth question is also there. First we have to write augmented matrix, then we have to transform it using operations or applying in the form of 100, 010, 001, 210. So here x equals to 2, y equals to 1, z equals to 0. And similarly, another question is also given, and this is also in the same way. You can see and observe how the operations are used. Note: matrix inversion method is not applicable when data equal to 0, and tedious when A contains many rows and many columns. In such cases, Gauss-Jordan method is useful to solve the system of linear equations. We have discussed about Gauss-Jordan method of solving the system of linear equations. Quiz. So, see the quiz. See the quiz here. I will try. In Gauss-Jordan method, the matrix formed with the coefficients of x, y, z and the constants on the right side of the given equations is called what? So answer is A, augmented matrix. So assignment is given. solve the equations 2x plus 3y equals to 13 and 5x minus 4y equals to minus 2 by Gauss-Jordan method. So here 2 by 2 matrix and 1 0 0 1. So we have to form, and third column as it is alpha beta. And second question is containing x plus y plus z equals to 6, x plus 2y plus 3z equals to 14, x plus 4y plus 9z equals to 36 by Gauss-Jordan method. One more question is there. So this is and some example problems in the textbook also there. So before listening the video, first see the PPT, because PPT is also available separately. Listen the PPT and see the PPT and note down the problems which are in the PPT. Then you can see the video, then you can listen the video. It is easy, and screen clarity may not be problem to you if in the video, because you already watched the PPT or see the PPT in another device. Then it is if it is not clear in the video, but voice is very clear, but sometimes some symbols are in PPT presentation, there may be sometimes not clear. So that's why you can first read the PPT and note down the problems, then listen the video. You can easily understand, and example problems are also available in the textbook, and do understand and then go for exercise problems. And if you have any doubts, ask me or mail me. And this is the important method. 3 methods we have, so these 3 are important. From these 3, 2 are asked in the examination, so there is a chance sometimes 3 maybe comes. So better perfect 3 methods. Do the problems on 3 methods. Okay, thank you.